Hey guys, welcome back. Today is day 56 and we are going to talk about simplifying square roots and cube roots. So before we get into this, we're going to talk first about the symbol. So if I had the symbol that looks like this, that is called the radical. The whole thing is called the radical. All right. The X is the little number that's in the corner here. All right. Sometimes it's a 3. Okay. Sometimes it could be a 4 or a 5, but in algebra, we usually have it either a 2 or a 3. But when it's a 2, it actually is just blank. So it's implied to be the square root. But if you have a little 3 there, it's what we call the cube root. Okay. So the X itself is called the index. So if we set it up like that, the X would be the index. So in here, the value X is called the index. All right. A lot of times it's either a 3 or if it's nothing, it's a 2. And the Y in this example here, if we had this, the Y is known as the radicand. Okay. The radicand is the term that is underneath the radical sign. All right, the index tells you what you're taking. If it's a 2, it's the square root. 3 is the third root. 4 is the fourth root. 5 is the fifth root. If there's no index, and this is really important, no index, we assume it's the square root. Okay. All right, so let's look at thinking about perfect squares first. Okay, so this first couple of tables should be really easy to fill out. If you had a value of an input of 1 as being an x, if you squared it, 1 squared would be 1. 2 squared is 4. 3 squared is 9. 16, 5 squared is 25, all the way down. These are all our perfect squares that you should have heard about before. Okay. And this is 81, and this is 100. We keep going. 11 squared would be 121. We have 144. 169 for 13. 14 squared is 196. 15 squared is going to be 225. 16 would be 256. Then we have 289 for 17 squared. 18 squared is 324. 19 is 361, and 20 squared would be 400. Okay, so the inverse of squaring something is taking the square root. So when you square root a number, it gives you a whole number. Then it's called a perfect square. So the square root of 1 would be 1. The square root of 4 is 2. 9 is 3. 16 is 4. We've got 25. 36. We've got 49. 64, got 81, 100, then we've got 121 and 144. So if we take the square root of those numbers, we end up with a whole number, then it is called a perfect square. All right, so pause the video right now and just try to simplify these. It should be pretty easy. I'm going to go through and give you the answers. You can stop it and check if you'd like. So square root of 36 is 6. Square root of 100 is 10. We've got 7, 5, 8, 2, 9, 12, 4, and 3. Okay, so those are all perfect squares in the radicand. So we took the square root of each one of those. Okay, so now to simplify the radical, our whole goal, we're going to show you a couple of different methods. The whole goal is to have no perfect square or cubes under the radical. So we want to take what's in the radicand, and in the example A, I'm going to start with radical 40. Okay, so let me see. We've got radical 40. So in this case, 40 is known as the radicand. Now I can split 40 into the square root of 4 times the square root of 10, okay, because 4 is the largest perfect square factor. So I can then take the square root of 4 and I get 2, and then 2 radical 10 would be my solution. Okay, so this method is good if you know your perfect squares and know your factoring. All right, if I looked at B, B is radical 27. Okay, I can represent 27, the largest perfect square factor. Think of your perfect squares. You've got 1, 4, 9, and then 16 and 25. So I'm looking for my largest perfect square factor. In this case, it would be 9. So I can represent this as the square root of 9 times the square root of 3. Well, the square root of 9 is 3. So this would become simplified as 3 radical 3. All right. If I looked at example C, okay, in this case, notice we're only looking at what's underneath the radical sign. We're only looking at the radicand. So the 3 is going to actually be multiplied later. So I'm not going to forget about that. All right. So I've got 3 radical 32. So I can represent 32. Again, I think of my largest perfect square factors. I've got 9, I've got 16, okay, and then I've got 25. All right, so my largest perfect square factor in this case would be 16. Okay, so I can say this is equivalent to 3 times 16 times 2. All right, so 16, yep, so I've got the square root of 16 in this case would be 4, so this would be 3 times 4 radical 2, and 3 times 4 is 12, so 12 radical 2 would be the simplified version in example C. Okay, now this method works well when you do know your perfect squares and you know that they're factors, okay? But have no fear if you don't, okay? We're finding that a lot of students do a lot better with method number 2, which is using a factorization tree, okay? So you may have done this in the past. All right, so we're going to start with the number 40. I'll give you some examples. And you're going to think to make a factorization tree, you want to come up with 2 factors. And it doesn't matter which 2 factors you use. You could use anything to get 40, okay? You don't want to use 40 in one because you'll get nowhere. But you could say maybe 2 times 20, 4 times 10, 5 times 8. It doesn't matter what you start with. I'll start with 4 times 10, okay? So 4 is not prime. Prime, remember, prime is a number that only has 2 factors, one in itself. So I'm going to continue to factor 4 with 2 times 2. All right, so when I get to 2 times 2, I know I can't go any further because they're both prime. All right, and then 10, I can say 5 times 2. So what I like to do is I like to circle, okay, all the prime factors. Now I need to look for, because my index is 2, all right, notice there's no number there, so that's really a 2 for my index, meaning I'm finding the square root. 2 means I need to find my doubles, okay? So all my doubles that I have, in this case I've got one set of 2 doubles, so I'm going to pull that outside of the radical. All right, so 2, and then what's left over, if I can't match them up, I'm going to multiply it together, and I get 5 times 2, so, oops, that's a times. My final answer is 2 radical 10. All right, so notice we did the same as we did in example A, the first method, okay? And we're doing the same thing with B, okay? So these are just showing you the 2 different methods with the same examples. So radical 27, all right, I'm going to start with maybe 9 times 3. 3 is prime, so I'm going to circle it, and then I've got 3 times 3. All right, since my index again is 2, I'm looking for my doubles. So I've got one set of double 3s, so I'm going to cross those out and write down 3, and then what's left over is going to go as the radicand underneath the radical sign, so it's 3 radical 3. All right, same as our example that we had using method 1. All right, now with C, because I have a number outside of the radical sign, I'm going to actually circle it, and I'm not going to forget about it. So I'm going to bring it down, okay? Because a lot of times kids forget about that. So I'm going to bring it down. There's my 3. 32, okay, I'm going to say, let's say 8 times 4, okay? 8 times 4 is 4 times 2. 8 is 4 times 2. 2 is prime. I'm going to circle it. And then I've got 2 times 2. And then 4, I've got 2 times 2. All right, so I'm going to write my 3 a little lower, okay? So now I'm looking for my doubles because, again, my index is 2. So here I've got a set of 2's, and I'm going to write times 2. And then I've got another set of 2's, times 2 again. And then what's left over is going to be the 1, 2. So that's going to be sitting inside the radical sign as the radicand. Now I just multiply 3 times 2, 6 times 2 is 12, and I get 12 radical 2. Okay, so there's our 3 examples. All right. Now at any point, I highly recommend pausing this video and trying some of these on your own, okay? But I'm going to fly through this kind of fast just for purposes of the video, okay? Until you start getting the hang of it, I do recommend that you try them yourselves and check the key that's on Student View. So with 20, maybe I start out with 5 times 4. 5 is prime. 4, I can say 2 times 2. All right, so now I'm looking for my doubles because my index is 2. So I'm going to pull out a 2, and then what's left over is just the 5, and that goes inside. So 2 radical 5 is simplified. Okay, I could have done it the other way by saying 4, 5, and then recognizing the square root of 4 is 2 and 2 radical 5. That was the first method. Okay, so with radical 8, I'm going to do 4 and 2. 4 is going to be 2 times 2. All right, I'm looking for my doubles, so I have a double 2, and what's left over is just a 2, so it's 2 radical 2. All right, the other way, I could have said it's 4 is my largest perfect square factor, 4, 2, and that would be 2 radical 2. Okay, with 90, I could say 10 and 9. For 10, I can say 5 times 2, and they're both prime, so I'm going to circle them. 9, I can say 3 times 3. I pause, I look, okay, my index is 2, so I'm looking for doubles. I've got double 3s, I pull it out, and then what's left over is 5 times 2. So we end up with 3 radical 10. Okay. For 300, maybe I start with 30 and 10. Then with 30, I can multiply 6 times 5. 5 is prime, I'm going to circle it. 6, I can do 3 times 2, and they're both prime. And with 10, I can say 5 times 2. All right, I pause. My index is 2, so I'm looking for doubles. So I've got double 5s. I'm going to pull that out. I've got double 2s. I'm going to pull that out. And what's left over goes underneath the radical is going to be, as the radicand, is just going to be a 3. 5 times 2 is 10. We end up with 10 radical 3. All right, number 5, be careful. Your index here is 3. That's different now. So now, instead of finding our doubles, we're going to find triples, okay? We're 3 of a kind, all right? So I'm going to start out with 200 and say this is 100 times 2. And with 100, maybe I'll do 25 times 4. In 25, I've got 5 times 5. And then with 4, I've got 2 times 2. So as soon as you get your prime number, just circle it and end that branch. Okay, because I'm looking for my triples, or 3 of a kind, I've got to look and see I've got 2, 2, and 2, so I pull out a 2. All right, but I don't have any 3, 5s, so I don't have any other triples. So what's going to go inside of the radical sign is 5 times 5. And what you cannot forget, and this is super important, this is the cube root. So we have to write in the cube root. All right, so our final step, we would just say 2 cube root of 25. And there's our answer in simplified radical form. All right, number 6. Now this time we've got a number on the outside. I don't want to forget about it. All right, I'm going to pull that down. So I've got 76 is 2 times 38. Okay, 38, I can say 19 times 2. All right, and when I look at this, I'm looking, my index is 2, so I'm looking for my doubles now. So I didn't forget, I brought my 2 down. Now I've got one set of double 2s and the radical 19. So this becomes 4 radical 19. All right. Number 7, I'm going to get 12 and 9. I'm not going to forget to bring down my negative 5. 12, I've got 6 and 2 and maybe 3 and 2. 9, I've got 3 and 3. Okay, so in this case, we're looking for our doubles. I've got double 3s, and then I've got double 2s. All right, what's left over is going to be just that 3. So when I multiply across, I end up with negative 30 radical 3. All right. Okay, for number 8, the first thing I notice about number 8 is, well, one, we've got a negative 4 outside, so I don't want to forget about that. So I'm going to bring that down to the bottom. Okay, the other thing I notice is my index is a 3, so I am looking for triples here. Okay, this is really important. Okay, so now I'm going to start taking what's underneath the radical sign, and I'm going to start factoring it. So it doesn't matter, again, what you start with. Maybe you decide to just start with it's divisible by 2 because you know it's even. So 2, and that would be 50. That would be 52. Okay, so 52 is not prime, so we're going to continue on, but it is even, so I could say 2 times 26. All right, and then 26, I could say 2 times 13. Okay, so there's all my prime numbers. Since I am looking for triples, if you notice, I've got 1, 2, 3 2s, so I'm going to say times 2. All right, and then what's left over is just the 13, but I'm also not going to forget it's the cube root. Okay, so now I multiply -4 times 2, and I get -8 cube root of 13. Okay, so number 9 is similar to 8, so maybe you want to pause the video and try number 9, but I'm going to go ahead. I know I've got a 3 on the outside. I don't want to forget about it. I'm going to bring it down. Okay, this is again an index of 3, so I'm looking for my triples. Okay, PLES. Okay, I'm going to take 216. I do know it's even, so maybe I can say 2 times 108. 108, maybe I'll do 12 times 9. 12, I've got 4 times 3. And for 4, I could say 2 times 2. All right, the other branch, my 9, I could say 3 times 3. Okay, so now, again, I'm looking for my triples. So I've got triple 3s right here, 1, 2, 3. And then I've got triple 2s. Yep, there's one up there, 1, 2, 3. Okay, now notice I don't have any prime numbers left, so there's not going to be anything that goes in, there's nothing left for the radicand. So I'm just going to multiply 3 times 3 times 2, and when I do that, I get 18. All right, so what that means, okay, is I don't need the radical sign. All right, so the number 216 is actually a perfect cube, we call it. So meaning that if we took 6 times 6 times 6, we would get 216. So we ended up with 3 times 6, which is 18. Okay, so moving on. All right, now if the radical contains any variables, now this is going to be important. We're going to write it out and find the pairs and the triples. Okay, so we're going to kind of think about it like all right, we're going to look at the 72 first. Okay, look at the number piece or the coefficient piece first. So I've got 9 times 8, and then I've got 3 times 3. Okay, and then I've got 4 times 2 and 2 times 2. Okay, so I am looking for my triples. So I need 3, and I look at the number piece. I've got 3 2s. So the 2 comes out. All right, I'm going to leave a little bit of space. Okay, and then what's left over is 3 times 3. And I know I've got my cube root, so I'm going to put that little 3 there. Okay, now I'm going to look at my variables. So with my variables, I've got x to the 4th, so I'm going to write 4x's. And I've got y to the 3rd, so I'm going to write 3y's. Okay, it's going to work similarly to how we did the prime factors. I'm going to look for my triples. Okay, notice I have one set of triple x's, so I'm going to pull that out, and I have 1 left over. Okay, now with my y's, I'm going to pull out 1 triple set of y's with 0 left over. Okay, so my final step here would be just multiply the 3 times 3, and I would get 2xy cube root of 9x. That would be in simplest radical form. Okay, I'm going to switch colors here so we have enough room, and we're going to try number 11. So we've got 450, so I've got my 6, I don't want to forget about that. 450, I'll do 45 and 10. 45, I can do 9 times 5. 5 is prime. 9, I can do 3 times 3. Oops, I didn't leave enough space. So I'm going to actually erase my 6 and bring it down a little bit further. Okay. Okay, so that's 6. All right, now with my 10, I've got 5 times 2. All right, and since they're both prime, I'm going to circle them. All right, so in this case, my index is 2, so I'm just looking for my doubles. All right, so when I look for my doubles, I've got a double, let's see, double 5s. So I'm going to say 6 times 5. Okay, and then let's see, we've got double 3s. So let's say times 3. Okay, and then what's left over, I just have my 2 left over, so I'm going to leave some space. I'm going to make my radical sign, and I'm going to put a 2 inside. Okay, now let's look at our variables. We've got x squared, so 2x's, all right, which means I've got one pair of x's I'm going to pull out with none left over, and then I just have a y. Well, I don't have any doubles, so that's going to stay inside. All right, so when I multiply it all out, I've got 6 times 5, which is 30, times 3 is 90, x radical 2y, and there's my answer. Okay. Let's switch back to a blue color so we can see it. Okay, so I've got a negative 7. I don't want to forget about it. I'm going to pull it on down. I've got 168. I'm going to start factoring that. I'll do 42 and 4. Okay, 4 I can do 2 times 2. Circle both of those. 42 I can do 7. Let's do 6 times 7. And 6 I can do 3 times 2. Okay, so I took apart, I factored out the coefficient to a product of prime numbers. All right, and from here, I'm looking for my doubles. So it's going to be negative 7, and I got double 2's, times 2. And then I don't have anything, let's see, I don't have a 3, a 7, and a 2 left, so I'm going to leave some space for my variables, and I'm going to put in 3 times 2 times 7. Okay, the ones that are left. Now for my x's, I've got 6 x's, 1, 2, 3, 4, 5, 6, okay? And since I'm looking for my doubles, I'm going to say there's 1, 2, and 3. So you could also think of what's 6 divided by 2, and then you would get x, and it would be to the third, okay? Because we got 3 pairs of x's. All right, and then for our y, we've got 1, 2, 3. All right, so what happens is we've got 1 pair of y's and then 1 left over. Okay, so now when I multiply everything out, I'm going to kind of come down here and do negative 14, x to the third, y, radical, 6 times 7 is 42, and then I have a y. There it is. Okay, so these get a little confusing, so I really want you to pause and try the next yourself. Okay, and I will go ahead and actually do these. Okay, so I'm going to bring down my 2. I'm looking for triples. 3 times 9, 3 times 3. Okay, so in this case, actually, I've got 3 3s, so I'm just going to pull that out. I don't have anything that goes inside, but I might have some variables, so I'll wait and see if I do. I've got x to the third. I'm looking for triples. I've got 1 set of triple x's, and then for our w's we actually have 9. So if you want to kind of divide by 3, you can think of 1, 2, 3. Okay, so your w is going to be cubed. Okay, 3 sets of the w's. When you multiply it out, you get 6xw cubed. Nothing to put under the radical, so we just leave it without it. All right, looking at 14. All right, 289. I'm not going to forget about this negative. I've got to bring that down. All right, and we've got 289. All right, we're going to start with 289 and say it's actually a perfect square. It's 17 times 17, and they're both prime. So 17 comes on out, and don't forget that negative, so it's negative 17. Now let's look at our x's. We have 7 of them. All right, when we think of pairs, we've got 1, 2, and 3, so we'll say x to the third, and then what's left over is just 1x. Okay, with our y's, we've got 3 of them, so we have 1 set of y with 1 left over, and then z's, we just have 1 set of z's, so that would come out. All right, so our final answer would be negative 17, x to the third, y, z, radical xy. Okay, and we've got one more. All right, this one we're looking for our triples, so we're going to bring our 5 down so we don't forget about it. All right, 56, I'm going to do 7 times 8, circle my 7, we've got 4 times 2, and then we've got 2 times 2. Okay, so again, we're looking for our triples. So I've got triple 2's, so I'm going to pull that out. And now looking at what's left inside, we've got just the 7. Let's look at our variables. We've got x to the 8th, 3, 4, 5, 6, 7, 8. We're looking for triples, or you could think of 8 divided by 3 is 2. So it would be x squared with 2 left over. So x squared. And we don't want to forget about that cube root. Our final answer, when we multiply out, we'd get 10x squared cube root of 7x squared. And that would be our answer. Okay, thanks. Bye.